notice that I put up some of the answers to the Cycles worksheet. I didn't put all the answers up because this is part of you're going to turn this in with your collected 4, and a few of the problems I'm going to grade for based on right or wrong. So I left a few for you to have to figure out on your own. But anyway, if you check these answers and they're correct, then stop the video and move on. If you need help with any of these, then let me go over them. All right, so we've got this Ferris wheel, and in the first example, start at the bottom. One Ferris wheel goes around every 50 seconds. All right, so once around is 50 seconds, so then it would go twice around in 100 seconds. Right, but we've got this smaller Ferris wheel, right, that goes once around in 20 seconds, twice around in 40 seconds, right? So it would have made it twice around before this one even made it all the way around, right? But what we end up needing to know then is how many cycles would it take for them to both, both be at the same place at the same time. Okay, and this one will go 3 times around in 60 seconds and 4 times around in 80 seconds and 5 times around in 100 seconds. So after 100 seconds, this will have completed 2 cycles, this will have completed 5 cycles, but this is when we're at the same place at the same time. So what I just found here is an LCM of 50 and 20. Right, so I could use any of those rules that I learned on that last exercise, right, where I multiply the 2 numbers, divide by the GCF, right, which would be 10, right, or what I showed down here is actually the list method. So same idea here for letter B. Okay, in letter B, again, finding an LCM, so let's multiply 45 and 25 and divide by the GCF. All right, GCF would be 5. I know it would be 5 because 5 into this is 9, 5 into this is 5. 9 and 5 are relatively prime. So I would do this to get 225. I might have mentioned that D is a trick question. Usually I give the hint when we're doing this that there is a trick question in here. Because what happens in letter D is if we're talking about when they will all be at the top, okay, so not the bottom, at the top, all right, and so for the 50-second ride, you're at the top at 25 seconds, and again at 75 seconds, right, because 50 seconds later, 125, you're at the top again, 175, you're at the top again. So I keep on adding 50 to these. All right, now the first time I'm ever at the top, if I'm on the smaller one, is at 10 seconds, right, since it's got a 20-second cycle. Then I'll be at the top again. I keep adding 20 at 50 and at 70, and we can see this is always going to end with a 5. This is always going to end with a 0. All right, so it's never going to happen that they are at the top at the same time. So continuing on, in number 2, B, you're just finding the LCM of 88 and 224. So I would use my method of multiplying 224 and 88 and then dividing by the GCF. And I'm thinking the GCF is 8, okay, but I'm going to use my method, the Aaron-Harris method, where I check this out and see if the GCF is in fact 8, because I'm not even sure that 8 goes into 224, but I'll figure that out in a minute. So 8 into, here's 11, so let's see, that would go twice, 64, so 28. Okay, so if I look at 11 and 28, 28 is 4 times 7, no common factors with 11, so I know this would be the correct GCF. All right, so I would find this answer here by doing that. Okay, and then the last one I'm going to go over, and I don't know if this is some really scientifically proven thing or if this is just someone's theory about, these cycles. But anyway, we have a 23-day cycle, a 28-day cycle, and a 33-day cycle. So I can't use my favorite method here, right? Because there's 3 numbers, so I can't just multiply and divide by the GCF. So I had said in the last clip that the best bet for 3 numbers is prime factorization, I think. So a prime factorization of 23 is 23 because it's prime. All right, so this is 4 times 7, which makes it 2 times 2 times 7. And this is 3 times 11. What this means is that none of these 3 numbers have any factors in common. All 3 of them would be considered relatively prime. So when it comes to finding an LCM then, I take the highest that each one has, right? So that's going to be 2 squared times the 3 times the 7 times the 11. In other words, the LCM is just the product of the 3 numbers. Okay, this would be a case where if you were doing the list method, it would be so long because you would be writing out 28 multiples of 33, right, before you found a place where they were in common. All right, so the LCM is simply the result of taking the product of all 3 of these because they have no factors in common, and that's how I get my answer.